airplane's power plan includes the engine, propeller, and the engine accessories. Not only does it provide thrust, allowing the airplane to accelerate and climb without assistance, but it also powers the various aircraft systems by providing electrical power and driving fuel, air, and often hydraulic pumps. At the heart of the power plant is the reciprocating engine, which produces power by burning gasoline inside its cylinders. This causes the back and forth or reciprocating movement of a piston inside each cylinder. Each piston is connected to a rod which translates this back and forth motion into the spinning of the engine's crankshaft. The engine operates on a 4-stroke cycle. The first is intake. An intake valve opens, allowing a highly flammable mixture of vaporized fuel and air to rush into the cylinder. When the cylinder is filled, the intake valve closes. Next is compression. As the piston is driven upward by the motion of the rest of the engine, it tightly squeezes this flammable mixture into a small space near the top of the cylinder. Third is the ignition or power stroke. A carefully timed firing of the spark plug ignites the fuel-air mixture, resulting in a great deal of heat and pressure inside the cylinder, which powerfully forces the piston downward. The exhaust stroke finishes the cycle by allowing the spent exhaust gases to escape through the exhaust valve as the piston rides to the top of the cylinder once again. When the piston reaches the top of the cylinder, the exhaust valve closes and the cycle begins again. The intake and exhaust valves are held closed by springs and opened by a camshaft. As the engine turns, it drives the camshaft, which is shaped with strategically placed lobes along its length. These lobes open the intake and exhaust valves on the different cylinders as the camshaft rotates. Reciprocating engines are described by the number and arrangement of their cylinders. Common cylinder arrangements are radial, inline, V-type, and opposed. Opposed engines are the most common on small airplanes, since they produce good power pound for pound without creating very much drag as the airplane flies. In contrast to automobiles, airplane engines are air-cooled by the outside air, which is routed by baffles across the cylinders and engine. Each cylinder has fins, which allow the air to cool the cylinder more effectively. When an engine is air-cooled, a combination of high engine power and low airflow tends to cause the engine to run hotter. This situation is typically encountered during climb-out. The engine temperature gauge should be scanned to assure the engine's temperature limitations are not exceeded.